Okay, we'll take that out. Sophie, you're going to use that one on the Regents?
Yes, I
You're going to use that?
No, I forgot mine. It was on my
head. Oh, yes, I last time too.
I know, I keep forgetting. I'm going to put it in my bag.
Okay, so this chapter is all on probability. This is a huge portion of your Regents exam, is the probability chapter, so this is a good one to review. The first thing that shows up a lot is these like arrangement questions. And it's, I mean, you kind of, it's a formula, but it's not.
Thank you.
And what you guys want to remember is on the top, it's the total amount of letters. And on the bottom, each of these little, I wrote some hashtag things, but like, that's how many times each letter actually repeats. Instead of the top, you guys might also see NPN, but that's just more work in your calculator, so I like n factorial better. Okay. The big thing is when you guys calculate, you have to have the one gigantic set of parentheses around the bottom, otherwise your calculator thinks as a PEMDAS, so it messes it up, right? So when we go through the word arrangement, you want to look, what is the total amount of letters you guys say? 11 total letters. It's right in the back there, guys. Oh, okay. So we're going to use 11 factorial on top. Okay. Then we want to see what things repeat and how many times. Any ideas of things that repeat?
There's 4 T's.
There's what?
There's 2 A's.
2 A's.
2 R's. 2 N's and 2 D's.
Oh, wow, 2 A's. 2 R's. 2 N's. 2 D's. 2. Okay, I only see 1 T.
Oops, sorry, what was the last one? N.
E. Oh, E's. How many E's we got?
2.
2? That's holy cow. Okay. Alright, and again, you're really relying almost 100% on your calculator for this stuff. Give it one more double check. We have, yes, 2 A's, 2 R's, 2 N's, 2 E's, and nothing else. Okay, looks good. So when you guys type this in, we want 2 factorial to represent the first one, 2 factorial again for the second one, right, and so forth. Okay, you want to make sure it's written out like this with one gigantic set of parentheses. So you guys put it in your calculator. So we have so on the top we had 11. To get your factorial thing, you have to go to math and go to PRB and choice 4 divided by, right, and here's your gigantic set of parentheses. And you got to do 2 factorial, or just kind of things. Yeah, and just make sure you have that one gigantic set. If you forget the parentheses, depend that and maybe the whole answer. Everybody able to find the correct button? Yeah. If you want the multiplication, should be able to.
I really hope I'm doing this right. They don't look too small, too big.
Yeah, some of them are big. Some people like need 4 nanometers, some 5, some didn't. I was almost like the basic part was very okay. All right, so you guys simplify. Hopefully, all got this. Which was choice 1. You guys want to look at it? You guys write it all. How was that for everybody? All right, I bet you'll see one of those. We love those repetition stuff. Okay, it comes up a lot. The next one that comes up a lot is finding a specific term in the expansion is another big topic. It could be multiple choice, could be in part 2. The binomial expansion is given to you guys, right, on your reference sheet. And what they're going to ask you is about a specific term in the expansion. Now, you don't want to expand the whole thing unless they ask you to. So if they ask you for a specific term, what you want to do is think about the first one. The first little like set of information is the first term, then you have your second term, the third term. And if you guys look at like when you're dealing with the second term, all the exponents are 1s. When you're doing the third term, they're all going to be 2s. So if it was like the fourth term, it'd all be 3s. What do you guys think if for this one, if they ask us for the fifth term?
4s.
They're all going to be 4s. Good. So what we want to do is write down the formula first for what the fifth term would actually be. Right? It's always one less with the exponent. So we're going to have NC4, and then we have A to the N minus 4, and then B to the 4. Right? So what I'm doing is I'm switching out all these little exponents, right, with the 4. Because that would actually be, if I continued, that's going to be what the fifth term would actually be. Do you guys kind of see the pattern? We don't want to expand this whole thing and actually find the fifth term. We just do one part to be way easier. Okay. So with this, anybody know what the N is? What the N represents? Good. Yep. N is the exponent. Nice. It kind of looks like this. So N is the exponent. Good job. When you guys are doing the A value, be really careful you take the entire term. So what's the whole first part? 3A. Good job. Right. And the B is going to be negative B, right? You're taking the whole second part, including the sign too. So once you have everything, now it's kind of just subbing things in.
Sorry, it's on the 31. Alright, just come catch which one.
We're in 64. Now with the A, be really careful. Since you guys are subbing in something, it might help for you to do parentheses and make it like 3A is the A. And then we have N minus 4, so 6 minus 4. Same thing with the B. You're subbing in a negative B really for it, and then a tracer for it. You have a lot of stuff in here. We've got to be very careful with your math. We can't put this whole thing in at one time because we have A's and B's still in there. So what we want to do is figure out little parts of this. Does anybody know what 64 is? If you kind of forgot how to get there, we do the 6 first. You go to math, then go to CRB, and go to choice 3 where it says C, and then put your 4 in. And you get 15. Okay, so this part's 15. Now in here, 6 minus 4 is really 2. One place people get tricked is they forget to bring this exponent to both parts. Right? This exponent's got to go to both parts of it. So you're really doing 3 squared and then A squared. What is 3 squared? So 9, yeah. So it's like times 9A squared. And this is another thing. All right. When you guys have a negative base, but it's raised to an even exponent, what happens? It becomes positive, right? So this is going to be times B to the 4th, positive B.
So what was that have A?
Well, here's the thing, can you put in negative B into your calculator? No. So, I mean, you can kind of test the idea, like if you had, like, let's say, like negative 1 to the 4th, it would change it to be positive. But if you have like negative 1 to the 3rd, and it's an odd exponent, it stays negative. Okay, so kind of just using like your rule. Tricky. So at the end, once you guys finish everything, you want to multiply everything together that you can. So 15 times 9, multiply that. Oh no, I don't need 2 multiplication signs. What do you guys get? 16 times 9? 135. Good job. Okay. So we have 135 squared to the 4th. And like a lot of you guys may have kind of noticed this just going through your multiple choice. See how if you mess up even just that one little part by making this negative, they give you that as multiple choice option. So it's really tough to make sure you guys have it like perfectly correct. Right? You gotta look at each little part. Do they kind of remember those a little bit? Maybe. Now the next one I just put on in case they asked you guys, because middle term is kind of weird. With your expansion, okay, there's always going to be one more term than whatever the exponent is. So if your exponent for this one is a 4, that means that if you expanded this out, you would have 5 terms. There'd be 5 terms total. There's always one more than whatever the exponent is. So I want you guys to think about, even if you held out your fingers, right? If you knew that there was going to be 5 total terms, which one of them is the middle? The third one, good. So the middle term here is actually the third term. Okay. So it doesn't come right out and say find the third term. They try to be tricky with it. If you guys are ever asked to find the middle term, there's always one more than the exponent, so get that part first. Figure out how many total terms there are and then get the middle of it. So why don't you guys try this one out, right? Your third term is a nice one because it's actually given to you guys. Try it out on your own first. I'll kind of show you the work up here. You need to make sure your A, B, and N values are okay. The N should be 4, X should be A, B should be negative 3Y.
Will Sean Putnam please report to the main office? Sean Putnam.
What did you guys get with your 4C2? Anyone want to share? Good, good. And when you reduce this, you get an x squared. Watch out here that you bring into both. What's negative 3 squared become? Positive 9. Good job. And you also have to make sure you square that y. So then, at the end, when you multiply everything together, 9 times 6 is going to give us 54x squared y squared.
Good dad.
Just make sure you guys are watching your negatives. They like to throw a negative in the problem so it mess you up. Alright, so these are all really big topics for the exam. Okay. Here's one. We looked at the formula today. A lot of people were thinking like, oh, I can't remember how it was used. Right. This is going to be another huge, huge topic. When you're doing binomial probability, you'll see these keywords like exactly, at least, at most, and in the formula that we had to memorize. Okay, you've got to know this one going in, right? Because if you get this as a part 3 and you don't know it, we're kind of screwed. Right? You can't really get any points. So what we want to kind of review, right, is when to use it. So why don't you guys start by reading your first example. There's a big keyword that's kind of telling us that we need to use this formula. Yeah, you got it, Caitlin. Good job. All right, so they're talking about probability of winning a game is 3/5. Then the probability of winning exactly 3 out of a total of 4 games played is what? Well, the keyword exactly is what's telling you guys we need to use this formula. When you see exactly, at least, at most, even no more than, calculate the probability of something happening that amount of times, right? We want this formula. Now, another tough part is how we pick what the NRPs and Qs are. N is the total amount of things that you're doing. So how many total games do you have here? 4. Good, Ashley. Nice. So, Sophia? Oh, good job, good job. One thing that people get tricked up with is they mix parts together. So think about once you use this 4, you're not using it again for any other value. You're not making it to create anything. Okay. What about the R? It comes right after the key word. 3, yep. That's the easiest one to find. Okay. And now just make sure the probability that they give you is what they want to happen. Right? If not, you have to watch out to switch the P's and Q's. So just make sure they give you the probability of winning the game, and then they ask you the probability of winning. So the P is going to be 3/5. Does anybody remember how to do the Q? Yes, good job. 1 minus 3/5. What would that give you? 2 over 5. 2 over 5. It's always like what's left over. So you get 5 over 5. Get a whole. Okay. So once you have all this stuff, the plugging in part's not bad. So you can sub everything in. Make sure on your Regents you guys write the formula down and then show the subs. I wouldn't even show all this stuff. Right? If it's a question you have to figure out the point, you might be able to give you something for like knowing the formula and you can like some type of substitution. Even if it's not great. Okay. NCR, PCR, Q to the N minus R. There we go. So 4C3. Make sure your fractions are in parentheses when you guys put them in. And then R 2/5. Right? So N minus R is just going to give us. All right. You could plug this in, guys, all at one time. Now, I would actually do it all at once. Right? Make sure those fractions have parentheses. Now, one thing that comes up with these, a lot of times they do not tell you guys to round at all. So there's no rounding errors. You do not want to round unless we say it. If you could write this as a decimal, if you want to write it as a fraction, if you want to see if it goes into one, feel free. So either of those answers are acceptable, okay, but you do not want to round unless they say to round. Okay, really, really important. So you can do 216 over 625 or that 0.3456 here. If you want to be safe, you can always do a fraction. Right? If it says anything about exact, I would go with a fraction. Right? They've done it one time on a Regents, I remember. They said, what is the exact one? Even though no one rounded these, they still took off points if it wasn't in a fraction. So if you want to be safe, you can do fraction. Sometimes you try to go into one and it doesn't work. You can't. So, yeah.
If you put like both stuff, would you put like a decimal or a fraction?
Yeah, if that's a good idea. You could do both if you want to be safe, right? Just don't cross anything out. Like we can't grade information that's crossed out. But if you have like, 3 answers and one of them is right and it's not crossed out, we can take that one. You know what I mean? Yeah, that's okay. Yeah, that'd be fine. Totally okay. So either of those would work. All right, now this next one is like broken up into 2 sections. As long as you guys can read it through, and they like these type lately too, dealing with like multiple choice questions. I know I gave you guys a lot of these when we did this chapter. At most, we go down.
So there's the opposite.
Yeah. At least we go. Yeah, there's 2 parts. So I'll just read those 2 parts. Okay. So there's a math quiz given as 5 multiple choice questions. There's 4 possible responses for each question. Jennifer selects her responses at random on every question. So here's what I'm talking about. There's 2 steps to this. The first one asks you guys, what is the probability that she will select the correct response for at most 1 question? Right. So let's handle just the first part of this. Okay. So at most, at least, exactly. All right, those are all keywords. We still need to use the NCR, P to the R, Q to the N minus R formula. But, actually, let's get all of this off first. What's this N going to be? How many total questions do we have here? 5. Okay. And the math quiz has 5 multiple choice questions. Now, the R comes right after the keyword, and this part's a little bit tricky. You have at most, how many? 1. But when you guys are dealing with at least, at most, no more than, we have multiple R values. So if it says at most, okay, we need to go down until we get to 0. So we need to include 1 and we also need to include 0. Tricky. Now, the P is another tricky part. If you're kind of confused, like what's going on in here, what they're saying is that each one of these questions has 4 possible responses. So if you want to think about it like this, like question 1 has A, B, C, and D. How many of those are going to be correct? Only one of them. So 1 out of how many? 4. So the probability of getting you guys something a correct answer is 1 over 4. We like those lately, kind of making you guys come up with the probability yourself. Right? What would the Q be then? 3 out of 4. Good job. Awesome. All right. So when you guys calculate this at most part, what we would have to do is come up with multiple R values. We want to calculate this when R is 1. We also want to do this when R is 0. So we're going to plug everything in. 5, 3, 1. 2, 1. And you want to do the same thing with 0. So you're just going to change the R's and whatever you would have needed to do with subtraction, right? Notice it says nothing about rounding here, so don't round any of this stuff. That's the other. Did I say? Yeah.
No, I don't think I got that. No.
Oh, you just did 0 first. I didn't want to.
No.
Oh, that's what I said. Oh.
Oh, yeah.
Okay, so again, I know some of you guys asked me which one you'd rather have it less than. Okay, it doesn't matter to me which one. Okay, just make sure you are not rounding anything. I'm going to use the fraction 4, 5. Okay, all right. So then you're going to do the same thing on R0. Did anybody get the fraction for when R0? No, they won't. Okay, anybody else get that? You can do local. 5. Just 5? Okay, that would have been silly. Okay, if you need to use the top formula every time that you really review it, you know what I mean? Instead of just transform one thing. Okay, the ending parts, anybody remember what you need to do with the 2 values? Add them up. Good job, Lil. Right? You've got to add them. So now when you add these together, anybody want to share their answer? 81 over 120. Good. And that's like a reduced value. Okay? Yeah. That's good.
Wait, so you wouldn't like keep your bottom the same?
You could add them with 8. No, that's fine. If you guys did, like, so you already have a common denominator and you add them, that's fine. You could have made this, so if you added the tops, you would have got 648 over 1024, right? So that's what it means the same thing. It's just that your calculator will always give you like a reduced answer, so it reduces it for you. Yeah. Okay. How'd you guys do with this one? Right. Now, if you had at least, so the second part of this, if you guys don't want to actually calculate and you just want to make sure we can come up with the values, that's fine. If you want to calculate it, we can. But the second part of this says, what is the probability that she will select the correct response to at least 3 questions? So if you guys had at least, the difference, I mean, everything else would stay the same. We would still have our n being 5. The p is still going to be 1/4. The q would still be 3/4. But if it said at least 3 questions, anybody know what the r's have to be? 3, 4, and 5. Good. You always go up until you get to the end value. Right? So when you guys would calculate the second part of this, you would have to do an r is 3, when r is 4, and when r is 5, and then add all 3 of those together. Yeah. That's really long. Great. If you guys don't want to calculate it, you don't have to. Right. The toughest part is getting the NRP.
Wait, so Regents make us use both?
It could. Usually it's just one or the other, though.
These are so easy though, if you know which one.
Right.
They're like easy things.
Sophia, you're like 100% correct. Like you guys want these kind of questions, but I mean, if you don't know the formula, it really like you can't do it. So that's why we're going to be doing formulas today. Okay. And again, if you guys want to calculate it, feel free, but you don't have to. We'll move on for it. You said, oh, you already did it? Yeah. Oh. You just did it. I should have tried to see. 45 divided by 5. That's 1 minute. So you thought, even though it's not even I know. That's all we're done. Right, because it looks like it would, right? Yeah, that was good. I have work for today, but I looked at the second part of it and you get that one? Okay, awesome, Sophia. Good job. Bye. Bye. The last thing is for permutations and combinations. I think this might be coming up on your next part of what you're working on, like what you're doing tonight, so this might be helpful. They like these questions with multiple choice. They've been on with almost everyone, and it's another easy question. But you have to remember the difference between a permutation and a combination. In a permutation, the order is very important. So someone's gaining something by you like picking them. Some key words for permutation are the words like arrangement, people or things in a line. Because if you're waiting at Dunkin' Donuts in the morning, does it matter if you're first or last? Yes, the order you're in is very important for Dunkin' Donuts. If you're running a race, does it matter if you're first, second, third place? Yeah. If you try. Also, same thing, if you have people like running for office, like president, vice president, secretary, those people are in different spots, so their order is important. When you're dealing with a combination, order is not important. So you're going to see words like chooses, choices, maybe committees or groups. And when things are random, also the order does not matter. Like if I was going to make a group out of Caleb, Paige, and Anthony, does it matter if I choose Caleb first, Paige, then Anthony, or Anthony, Paige, and Caleb, just like make a group? No. If you're just choosing people and like no one's gaining anything, it's going to be a combination. When you guys set up your permutations and combinations, permutation is NPR in the calculator, combination is the NCR button. N is like always like the total. Right, R is like what you look for. Okay. The bigger numbers always first. A lot of times in multiple choice they try to like switch them. Right, you try to be tricky, but the bigger number always has to go first. Okay. So let's try to see if you guys can figure out which one of these is which, all right? So easy questions, but you gotta know the difference between a combination and permutation, and there's always some key words in here. So they have 20 different cameras will be assigned to several boxes. 3 cameras will be randomly selected and assigned to box A, which expression can be used to calculate the number of ways 3 cameras can be assigned to box A. Alright, well, Lily's thinking combination. Alright, you like the NCR one. Lily, what was your big key word in here?
Random.
Good. Alright, these cameras are picked randomly. They're just going into a box. And, you know, the first camera's not getting special treatment from the second camera. So when you guys go to match this up, how many total cameras did you have? 20. Good. And you're choosing 3 of them.
So 20 was this.
23. Yep, it is funny. We go first. It's a bigger number always. That's okay.
I was going to say, that's the bigger number.
Yep, always. Okay, let's try another one. And these are right off Regents exams. Like they're easy questions if you know keywords for things. Yep, people in a tennis club. How many of you can come in first, second, or third place in a tournament? What do we think? P's or C's? P. Yeah, what's your big key that you're using in permutation?
Place first, second, and third.
Great. Right. Anytime we're talking about places, like first, second, or third place. Right. How many total people do we have playing in this tennis club? 8. Good. And we want to pick, now, first, second, or third place, how many ways are these at? There's 3. Right. There's only 3 spots in there. Alright, so this 5 is kind of like random. I don't know why it says 5. Now number 3 is a little bit differently set up, but very similar. Okay, you guys did a lot of stuff like this, but it tricked you up a little bit. Okay, so they have a math club that's 30 boys and 20 girls. They want to know which expression represents the total number of different 5-member teams consisting of 3 boys and 2 girls can be formed. So your first thing you want to do is figure out, is anybody gaining anything if like with those 3 boys, does it matter if they're going to go onto this team? If like, you know, Johnny is going before Tyler is going before Dan? They're all, no. Okay, so is the order important here? No. So we should be using C.
So does it have to go like one boy and one girl?
Yes, exactly, Ashley. Good job. So you want to do exactly what you just said. It kind of segments it up because you're talking about 2 different groups, not just all one pool of candidates. So we have 30 boys, and how many do you guys want to choose of the boys? 3. Good. So we're going to kind of group those together. So it's going to look like 30C3. And then we're going to do the same thing with the girls. So with the girls, you have 20 girls, and you want to choose how many of them? 2. So 20C2. Now, the last part is between these, what do you guys want to do with them? Multiply. All right, the addition here is tricky, it's always multiply. Whenever you're calculating probabilities, like even back in like 8th and 9th grade, you're trying to do the total amount of things, it's always like adding and subtracting when you're doing a conditional. Right? Then you guys don't know that until like 7th grade. Yeah. So, but you want to remember like always multiply, that's what you guys do. Okay, last one here. Teacher wants to divide her class into groups. Which expression represents the number of 3-person groups that can be formed from a class of 22? Any ideas? All right, so we're down between 2 and 3, it sounds like. You don't know which one? Okay. You got 2.
I got 2.
Right. Caitlin, why did you choose 2? You're right.
One of them,
This right doesn't matter? Yeah, no, you're totally right. Good job. Right? If you guys are making these like 3-person groups, okay, imagine, it's kind of like what I was talking about with you guys. If I'm making a group of 3 people, does it matter if I choose like Ashley, you first, Lily, then Anthony? You're just going to go into some group over there to work? Do you get special like privilege for being the first one chosen? Maybe in your own like part or something. But not really. You're only going there to do your own job, like the same thing. So
I just thought like it was a different 3-person, I thought like maybe like different 3 people for each group.
Oh, okay. what you're saying. So this just means that you can't be like chosen again for like actually you can't be part two.
Yeah.
You know what I mean? Sorry. So it would be clean. Good job. All right, you guys are awesome. I hope this helps you.